All right, everybody, welcome back. Today we're going to do some numerical summaries, but instead of doing by hand like we had been doing, we are going to use a calculator today, which is good news. We're going to calculate the standard deviation there on 3 separate occasions. So rather than having to do that by hand, we can just plug it into a calculator and be good to go. So we're going to look at this distribution first, and we're going to find all of these characteristics or values. So we'll start off right with the shape. We kind of just go up, reach this peak, and then follow that same kind of trend downward. So the shape of this distribution would be symmetric. It doesn't skew in any direction. It has that one peak in the middle with about the same amount of data on the left as on the right. And again, now to find X bar, we're not going to do it by hand. We're just going to use the calculator for it. So if you just hit Stat, go into Edit, and use list number 1 and type in this data. I gave you a dot plot, so you do have the actual data here. There was 1 observation of 0, 2 observations of 1, so on and so on, until you get all the way to your 9th observation, which was a guy that had a value of 4. When you get the data entered, hit Stat, scroll over to Calculate. We are doing one variable statistics, hit Enter. Everything looks good here. We put the data into list 1, go down to Calculate, and it spits out everything that we really need. So we've got X bar equals 2. The standard deviation, S sub X, is 1.22. And then to get to the median, we're going to have to scroll all the way down. You're just hitting down until you get to this 5-number summary. So the median is also 2. The IQR, remember, it's just a single value. It's the distance between quartile 1 and quartile 3. So the difference between like 1 and 3. So the interquartile range is also 2. And the spread is the essentially the range. It's the difference between the maximum value and the minimum value. So the spread or the range of this data set is 4 minus 0. Okay, so one thing that I wanted to point out real quick on a symmetric distribution, the mean and the median are equal to each other. So if your distribution's ever symmetric or even roughly symmetric, these things should be equal to each other, or in terms of being roughly symmetric, they should be roughly equal, like in the same ballpark. They'll be pretty close to each other. Okay, so that does it for the first distribution. Now let's work on this distribution. We're going to do it 2 separate times. The first time we calculate it, we'll not use the outlier. The outlier is present right here. I know we haven't done like the IQR rule, but it's pretty obvious that this point does not belong with everything else over here. He's just kind of off on his own little island. And then we'll calculate it and actually include the outlier and see what happens to these statistics. It'll be a lot easier to do this on the calculator. So you have 2 options. Go to Stat, go to Enter. If you want, you can clear this list and retype all the data, or just scroll over to list 2 and start typing in the data. It's like you would type in 3 2s, 2 3s, on and on until you get to, we're actually going to have 8 observations for this list. Because again, I'm not including this outlier. And then just to pre-plan, you can do the same thing, but put it into list number 3. So anyhow, I'll go to Stat, go to Calculate, one variable statistics, and there's everything that we need. Okay, so the shape, by the way, I should have done this at the beginning, the shape. So we go up, and then we kind of just start to tail off here. We have a long lull, and then we get to that outlier. Okay, so the shape, not a perfect drawing by any means, but the shape is skewed right. It's skewed right because that's where the tail is going. Just write that for both distributions real quick. It is skewed to the right. So our mean that we found for this data set is not 2. What am I doing? Hey, so when you go to calculate, I forgot to do this. We need to change the list that we're pulling from. And to do that, you would just hit second and then come down here to 2. So we're calculating these statistics from list number 2. That's where I put the list. So anyways, go to Calculate, and our X bar is 3.1. Just going to round to the nearest tenth for this. The standard deviation is 1.1, and then I'll scroll down to get to the median. Median here being 3. The interquartile range, 2 to 4. So the interquartile range is simply 2. And the spread is, going from the min to the max, the spread is 3. Range is probably a better word for that. But anyhow, we should notice something. So the mean and the median, pretty close to each other. So without including this outlier, it looks like we almost have a symmetric distribution. If this point would have fell right here, then it would have been symmetric if I did not include the outlier. But not a big deal for this example. Now let's calculate these statistics, but we're going to include this outlier of 10. So one more time, I'm going to go to stat. I put my outlier into list number 3. I'll calculate my statistics. So my mean jumps up to 3.9. The standard deviation increased to 2.5. The median, I'll scroll down to get to my median. The median I got was 3. Interquartile range that I have is 2.5. And my spread going from the minimum to the maximum value jumped all the way up to 8. Okay, so I just wanted to have a brief discussion on what happens with extreme skewness or outliers. I know we've already talked about resistant in terms of the mean and the median, so this should make perfect sense to you. By adding this outlier, the median actually stayed the same. It didn't change at all. And again, that's because the median is resistant to outliers. It resists the pull that outliers have. The mean, on the other hand, absolutely gets dragged in that direction. So instead of being more like, the mean, instead of being really close to the 3, instead of my x-bar falling here, this outlier dragged him all the way to 4, or pretty close to 4 anyways, right? The median, again, just stayed at 3, but the standard deviation, look at that, we typically varied by 1.1 without the outlier. Adding the outlier, we more than doubled our standard deviation. We now vary by an average of 2.5. So the standard deviation is not resistant to outliers. Outliers and skewness definitely have a pretty big effect on the standard deviation. And of course, that's because the standard deviation is calculated using the mean. Okay, median we've talked about. The interquartile range, it changed. It went up by 0.5. Not a big change though, especially when you compare it to the standard deviation. I mean, standard deviation more than doubled, where this only increased by 25%, right? The spread, it also more than doubled. So the spread is another measure of variability that is not resistant to outliers. Outliers have a huge effect on the spread or range of a data set. Okay, so all I wanted to really talk about now is, remember SOX. We needed to be able to describe the shape, identify outliers, talk about the center, and also spread and variability. Okay, so your distribution is going to affect which values you pick for this. So your shape, for the shape, if your shape is symmetric or roughly symmetric, the measure of center that you should choose, because it's going to be better for you, it's going to give you more information. Again, if the shape is symmetric, the measure of center you should use is the mean. If a distribution is symmetric, you should absolutely use the mean. For spread and variability, if you use the mean, you're going to want to use standard deviation to describe variability. The spread certainly works, and if we didn't have the actual data, then we would have had to have used the range. We wouldn't have been able to calculate the standard deviation. We can still estimate where the center is for the mean, but you can't calculate the standard deviation. Okay, so again, if your shape's symmetric, use the mean, and also for variability, use the standard deviation. Okay, so alternatively, for your shape, if it is skewed in either direction, if you say skewed left or right, doesn't matter. If it's skewed left or right, sure, we're still going to list outliers if there's any. Now the measure of center for skewed, and even if there's just like extreme outliers like we had up here, the measure of center for anything skewed, you should absolutely use the median. And a better measure of spread or variability if you use the median is to use the IQR. That'll tell you the range in the middle 50% of the data. Like for the IQR, it did not include the outlier. This IQR right here didn't include the outlier in its calculation. It just used the first quartile and the third quartile. So the IQR is great for measuring variability because it does not include outliers. Okay, so that's going to do it for kind of the note section. Let me go to just a couple quick examples and we'll talk about them. All right, y'all, here's this first example. We've got the distribution of days of attendance for the students at this girls' school. And then what it's asking you to do is describe this distribution. So if I was to describe this distribution, I would probably say that the shape here is skewed. I'm sure you can tell me which direction. It is skewed to the left. Okay, and then the next thing you would do is list any outliers, if there are any. And then moving on to center, this is what I was wanting to really talk about here. Since it's skewed to the left, you'd be much better off measuring the center by the median. We would use the median to describe the center here. And then for spread or variability, you can absolutely use the range because it doesn't appear to be any just like massive outliers, but it's probably best if you just use the IQR. Use the IQR to describe the spread here. Let me just show you maybe one more example here. One more. So on this, notice how we just increase. We kind of had that peak. We have this peak, and then it just starts to go back down. So I would certainly say that this appears to be probably roughly symmetric. Okay, roughly symmetric. So that would mean to describe the center, you could use the mean. And since you're using the mean, and there doesn't really appear to be any massive outliers, for the variability, you would use the standard deviation, right? But there is a problem with that. I could probably write this stuff down for you. So again, the shape, mostly symmetric, roughly symmetric. It's not perfect by any means. Again, list any outliers. There doesn't really appear to be any. The center, I would use the mean. It looks like it would be somewhere around 7.5. Looks like 7.5 is roughly where the mean would fall. All right, and then so for spread or variability, we have an issue because we don't have the actual data. We know that 2 people fall in this range, but we don't know their exact values. So we can't use the standard deviation. So that being said, just use the range. Just do the max minus min for this. Which, by the way, I would say is probably 9.5 minus 6.5. So the spread here would be approximately 3. All right, guys, that's going to do it for this video for sure. I don't know how long I'm getting, but thanks for watching, and I'll see you in class. Goodbye.